Lesson 4-6. In this lesson, I'm going to show you how to prove triangles congruent by ASA and AAS. And I'm also going to show you another kind of proof called a flow proof, which uses arrows to show the flow of a logical argument. Let's take a look at postulate number 21, which states that when two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So what do I mean by this? If, for example, if angle A here is congruent to angle D and side AC is congruent to side DF and angle C is congruent to angle F, then triangle ABC is congruent to triangle DEF. All the vertices need to correspond when you're writing this. Now let's take a look at theorem 4.6, which states that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are said to be congruent. So let's illustrate this. If angle A is congruent to angle D and angle C is congruent to angle F. See, these two angles are consecutive angles here. And side BC is congruent to side EF. Then we can say that triangle ABC is congruent to triangle DEF. Example 1. Can the triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem you would use. Now, you don't need to prove these. You just need to write either ASA, AAS, and let's take a look at the first one. Part A. It states that this angle, of course, is congruent to this angle, and this angle is congruent to this angle. And by the vertical angles theorem, these two angles are congruent as well, but there's no postulate or theorem that's called AAN. Even if all angles are congruent for two triangles, that does not guarantee that both triangles will be congruent because the sides could be of different lengths. So this does not exist, and we can therefore write not enough info. And no sides are marked congruent. Now for the second one here, we know that this angle is congruent to this angle. This angle is congruent to this angle, so we have angle, 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 and then by the reflexive property of congruence, this side is equal to each other, so these two triangles share this side, so we can say they are congruent by AAS, theorem 4.6. Okay, now let's look at this picture. This angle corresponds to this angle, they're congruent. This side corresponds to this side, which they are also congruent, and then we got the vertical angles that are congruent to each other. So angle, side, angle. Angle, side, angle. So this will be the postulate that can be used to prove this triangle or these two triangles congruent. Okay, so now I'm going to show you the flow proof. Angle 1, given angle 1 is congruent to angle 4. I'm going to mark it in the picture, and side CF bisects angle ACE, So I'm going to mark that in my picture as well. I want to prove that triangle CBF is congruent to triangle CDF. Well, I'm going to analyze my picture here. I know these two angles are congruent to each other. And CF, these two triangles, which I want to prove congruent, share the side CF. And from here, I can tell that these two angles are supplements, and since angle 1 and angle 4 are congruent to each other, by the congruent supplements theorem, I can say angle 2 and angle 3 are congruent to each other. So let's begin. Angle 1 and angle 4 are congruent, and that's given. CF bisects angle ACE, so that's given. So then I can, from this box, I can draw an arrow and create another box and say angle 2 is congruent to angle 3. And I can't just state that, and I still need to provide a reason. So I'm going to create another box here and say angle 1 and angle 2 are supplements. And angle 3 and angle 4 are supplements. Therefore, by the congruent supplements theorem, angle 2 is congruent to angle 3. So here, the reason for this one would be the definition of supplementary angles. Alright, now I can continue. I've stated these two angles congruent. I stated these two angles congruent. Now I need to state that CF is congruent to CF by the reflexive property. So you can again draw a box and then write this and then reflexive. And then when CF bisects angle ACE, we can state that angle ACF is congruent to angle ECF. So therefore we can say triangle CBF is congruent to triangle CDF by angle, angle, side, angle, angle, side, angle, angle, side, congruence theorem. And example 3, given segment CF or side CF and bisects angle ACE, so these two angles would be congruent to each other. ACF will be congruent to angle ECF, and here I can write given. And CF also bisects angle BFD, so I can say angle BFC is congruent to angle DFC. So here I'm going to write given and definition of angle bisector and definition of angle bisector. Now that I've proved these two pairs of angles congruent, I can state that in the middle, CF is congruent to CF by the reflexive property, and therefore triangle CBF and triangle CDF are congruent to each other by the ASA congruence postulate. Example 4. You and your friend are trying to find a flag hidden in the woods. Your friend is standing 75 feet away from you. When facing each other, the angle from you to the flag is 72 degrees, and the angle from your friend to the flag is 53 degrees. Is there enough information to locate the flag? Since the measures of two angles and the included side, so this would be the included side, are known by the ASA congruence, all triangles with these measurements are congruent. So we can say the position of the flag is given by the third vertex, which is this one, since the angles, the triangle formed is unique. Example 5. You're working two spotlights for a play. Two actors are standing apart from each other on the end of the stage. The spotlights are located and pointed as shown in the diagram. So here are these are the spotlights. One's pointing at one actor and the other one is pointing at the other one. Can one of the actors move without requiring the spotlight to move and without changing the distance between the other actor? Well, the measures of the two angles here, 40 degrees and 90 degrees, the measures of two angles and a non-included side, so it would be this one, are known by angle, side, all triangles with these measurements are congruent. So this triangle formed is unique, and one actor cannot move without requiring the spotlight to move and without changing the distance between the other actor. So say if this actor were to move 20 feet this way, this actor would have to also move 20 feet, and the spotlight would have to move. So this one would move here, and then this spotlight would move here to form another triangle, right triangle, and they will have to be congruent to each other. So you cannot move without requiring the spotlights to move and without changing the distance. And that's it.